I'm hoping that I'll convince you why I think sleep is really important to consider in dementia research, and also why I think it's probably one of the most exciting times in dementia research at this moment, certainly that I've known since I started my job. When we sleep, we stop initiating voluntary movements and we stop responding as much to external stimuli, but we don't switch off. It's not just that we have a rest and stop doing anything. Sleep is a really active process, and it's complementary to wake. So processes during wake and sleep all help us to behave optimally. So this is a bit of it is a description of what is going on when you sleep. If you look at the bottom, we've got your 8 hours of sleep, and then we've got the type of brainwave processes that are occurring during sleep. And we measure brain waves by putting electrodes on people's head. So you start off in stage 1 sleep, so technically you're asleep, but if someone talks to you during stage 1 sleep, there's about a 50% chance you'll respond. So that's why it's quite hard to define sleep, really. Then you transition through stage 2 sleep, and then get to stage 3 sleep, this N3 here, the purple bit here. That's what we call deep sleep or slow wave sleep. I'm actually going to focus mainly on slow wave sleep, and I'll tell you why. So during slow wave sleep, there are these slow oscillations. The brain is all firing together in a slow rhythmic pattern about once a second. And nestled within these slow oscillations, you had faster spindles. And nestled within spindles, you have even faster ripples. And all this coordinated brain activity is how you lay down memories. And not just lay them down, you filter memories, and you decide what's important for storage. And that's all critical to long-term memory storage. So this slow wave sleep, if you look here, you have it at the beginning of the night mainly. This is when you lay down your memories and you sort out what's important to you, all unconsciously, of course. After you've had your slow wave sleep, you then transition back to another phase of sleep called rapid eye movement sleep, REM sleep. And that's when we dream, and you're paralysed, so not moving at all apart from the eyes, which move around as though you're dreaming, as though you're seeing things. So I'm going to focus on slow wave sleep. So why, as a dementia doctor, do I really mind about sleep? Why does it relate to Alzheimer's disease? That's because this period of slow wave sleep is absolutely critical, and we are just learning why it is so important. So if you look at this brain on the left here, there's low amyloid in that brain. Now you will remember, I'm sure from previous talks, that amyloid is the sticky protein, or one of the sticky proteins that is strongly associated, probably causes Alzheimer's disease. So amyloid, when people look down the brain, down the microscope at people's brains after death with Alzheimer's, they have amyloid in them. This brain on the left has low amyloid, and when this person sleeps, they have big, slow oscillations. Their slow wave sleep is really strong. The brain on the right has a high amyloid, and we can see that slow wave sleep is really reduced in people with high amyloid. So not only do you need slow wave sleep to remember things, you lay down your memories during slow wave sleep, it also looks like it's positive that amyloid is related to slow wave sleep. So there is more and more evidence accumulating that poor slow wave sleep causes deposition of amyloid. As you have one of these slow oscillations, there's a pressure change within the brain, and that sort of sucks fluid round the brain during slow wave sleep. And so you filter out toxins during slow wave sleep, including amyloid. So there's quite strong evidence that if you lose your slow wave sleep, your deep sleep, you then accumulate amyloid, and it looks more likely that you'll go on to get Alzheimer's, or if you were destined to get Alzheimer's anyway, you might get it more quickly. So poor sleep is both caused by Alzheimer's and leads to Alzheimer's, we think. So what can we do about poor sleep? Well, we need dark rooms to sleep in, quiet rooms. You might have to sleep by yourself if your partner's noisy. These things are quite basic things that, we're constantly getting sleep interruptions. It's probably bad for our brain health. Go outside. It sounds stupid, but there's far more light in daylight than there is in most artificial light. You can get special lamps that produce a lot of light, but daylight is the best. So physical activity, going outside. Get your brain hormones started early in the day. So we talk about 9 a.m. You want daylight on your skin, particularly your eyes, to get to the brain. And physical activity, you can re-entrain the biological rhythms, both physical activity earlier in the day. So be active earlier in the day. Obviously, don't eat too much or drink too much just before bed, because you won't sleep very well. And it's amazing how many patients we see who report insomnia and still have a cup of tea at bedtime. So caffeine stops you sleeping for a lot of people. Nicotine, alcohol. Alcohol gives you withdrawal about 4 hours after drinking. That will often wake people up. Even if it's only for a few minutes, it'll be one awakening. So really cutting out all those things, or reducing, some of them are hard to cut. It can be really helpful. Try not to get stressed out just before you go to bed. Sometimes you can't, that's an obvious piece of advice. And also, don't stress about not sleeping. Some of these slow oscillations, if you just lie still in a restful way, you will have some of these oscillations that help with brain function. So if you lie still stressed, you won't have brain oscillations. But if you're resting and you're awake, you still have some of the same processes.